All right, let's take a look at the spiral review for today. So this first question, they want us to find an equivalent fraction. And as we know, as long as we do the same thing to the top and the bottom with either multiplication or division, we can do whatever we choose, right? I'm going to choose easy. 2 times 2, that would give me 4. I'll do the same thing to the 3, multiply that by 2, that'll give me 6, and there's an equivalent fraction to 2/3. I'll do the same thing for 5/8, just multiply both the top and the bottom by 2. 5 times 2 is 10, and 8 times 2 is 16. Okay, so this next one, Joey's writing cards, and it takes him 1/16 of an hour to write one thank you card. So how many cards can he write in 3/4 of an hour? So essentially, let's do this. Well, let's do this a couple of ways. Let's do this first with a model. Okay, so if I take a tape diagram and I'm going to cut it into fourths. Okay, 1, 2, 3, 4, and then I'm going to, because I know that he writes 1/16, or in 1/16 of an hour, he writes one thank you card. If I divide each of these 4 up into 4 within them, I will get 16 by the end, right? So I'm going to divide these up into 4s. So there's 4, 1, 2, 3, and 4. 1, 2, 3, and 4. 1, 2, 3, and 4. And I meant to do that in a different color. I apologize, so that we can kind of see the difference between the 3/4 and the 16ths. So our 3/4 were here, here, here. Okay, so that, hopefully that kind of helps you. And now the purples, those are there's 16 of the purples. Okay, so if I'm thinking about these 3/4 of an hour, and I want to know how many cards he can write in that time, I'm just going to count these smaller boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, that tells me he can write 12 cards. A second way we could do this is to think about mathematically what we were just doing. We had 3/4 of an hour. Okay, we were dividing to see how many 1/16 we could get into that 3/4 of an hour. Okay, and we know we're going to keep, change, and flip because that's division of fractions. Okay, 3 times 16, that's going to give me, let's see, 18, carry that 1, 3 times 1 is 3, plus 1 is 4, and 4 times 1 is 4. Now, this is an improper fraction, so I want to divide. 4 divided, I know that 4 goes into 48 12 times. So, we've got the answer 2 times in 2 different methods. I think we're right. Okay. All right, just a division problem, pretty straightforward here. Can't put 18 into 4, so let's see how many 18s we think we could get into 49. 18's awfully close to 20, so I'm going to think about it that way. I can fit 2 20s in there probably, so let's try 2 for the 18s. 2 times 8, 6. 2 times 1 plus 1 is 3. Okay, subtract. 9 minus 6 would leave me with 3, and 4 minus 3 would leave me with 1. Okay, I can't put 18 into 13, so let's bring this 6 down. All right, how many 20s, let's say, could I get into 136? Well, let's see, that would be about 7. I'm going to try it over here just to make sure. 18 times 7, that would be 6, carry the 5, 7 plus 1 plus 5. That would leave me with 12. Okay, that would work. So do 7, and I've already done my math, so I'm just going to bring that over here. 126. When I subtract 136 and 126, I'm going to be left with 10. Okay, let's bring down the 5. Now I'm going to kind of look at these two and realize they're just a little more than 20 apart. And that's really close to that 18. So I think just 1. That is not what I meant. Not 1. That doesn't make any sense at all. Okay. It needs to be a 5. I apologize. So 5 times 8 is 40. 5 times 1 plus 4 is a 9. Okay. Goodness, I hope you guys recognize teachers make mistakes all the time. I'm sure you know that by now. Thanks to your math teacher. All right. So bring down that 0. Okay, so we've been getting kind of close in here, but not quite that high. So let's try 8. Okay, 8 times 8 is 64. 8 times 1 is 8, plus 6 more is 14. Oh, this is not looking good, is it, guys? Okay, well, let's keep trudging along. So 10 minus 4, it's going to leave me with a 3. Can't leave a remainder in 6th grade, we know that. Okay, so let's do another 30. 18 will go into 30. How many times? Just one time, right? Oh, I think I messed something up here. I did. Oh, gracious. Not my best problem, is it? 10 minus 4 is 6. And then pull that 0 down. Okay, now, how many 18s can we get into 60? Well, that's going to be 3, I think. Will be close. So that will be 24. Carry the 2. Stick that in there. 3 times 1 plus 2 is 5. Okay, and now I think we're going to be just repeating here. Because now we'll add that 0. We'll be back to 60 and doing the same thing over again. So I think that is where we could put our line, that's the number that we'll repeat. Whew, sorry, that was a rough one. 275.83 is our final answer. Okay, now we're going to subtract with some decimals. Hopefully this is getting more comfortable to remember, depending on the math, what we do with those decimals. But in case it's not, let me remind you, when we subtract using decimals, addition and subtraction, we're going to line our decimals up, right? So if the decimal needs to go there, then 9 here, 2 here, and 1 here, okay? So now we're going to subtract. If it bothers you that nothing's there, just put a 0. Okay, 9 minus 0 is 9. I can't take 1 from 0, so I got to run next door. 10 minus 1 is 9 as well. Can't take 9 from 6. But I can do 16 minus 9. That'll leave me with 7. 7 minus 2 is 5. And our final answer here is 57.99. Okay, next up, we are looking for the least common multiple of 6 and 7. Multiples are many, right? Meaning we're going to skip count by these numbers because we could go on and on forever for many numbers. Okay, so 6, 12, 18, 24, 30, 36. I'm going to keep going because none of these seem like 7s yet. Okay, 36. Oh, there's one I know is also a 7 multiple. Okay, let's go by 7s. 7, 14, 21, 28, 35, and 42. Okay, I think that's our least. That's the first one we ran into for both of those numbers. So 42 is the least common multiple of 6 and 7. Okay, looking for unit rate. So we're trying to get these fractions down to the 1. Okay, and they have done part of it for us, but we want to find these top numbers. So what would I have had to do to the 3 to make it a 1? Well, I know that if I divide any number by itself, it's going to give me 1. So let's try and divide 18 by 3. That's nice and comfortable. 18 divided by 3 is actually 6. Okay, not too bad. Let's see how this one goes. So 2 to get to 1, same thing, just divide it by itself. That would give me to 1. So let's try the same thing here. Let's divide by 2. 12 divided by 2, they're both 6. Okay, so both of their unit rates are 6 over 1. Okay, there are 6 minutes of commercials for every 24 minutes of television. How many minutes of commercials are there in 1 hour and 36 minutes of television? There's going to be a couple of parts to this one. So first we have this ratio of commercials to TV of 6 to 24. And because I know I'm trying to find more, I think it might be a good idea to see if we can get this down to its simplest form. Hopefully maybe the rate, okay? And looks good. I know that if I get 6 down to 1, I would do that by dividing by 6, right? That would give me 1. And I can also divide 24 by 6, and that would leave me with 4. So for every 1 minute of commercial, there's 4 minutes of TV. Okay, now here's the next thing I need to take care of. This is not all in minutes, right? And we want to always make sure we're comparing the same unit. So I need to first get all of this into minutes. I know in 1 hour there are 60 minutes, plus this 36 minutes. So if I add that all together, that gives me 96 minutes, okay? That's the TV. So what I need to find out now is what would I have had to do to get from 4 to 96? Let's take a look and see if we can just comfortably divide that without making too many changes, okay? So 4 would go into 9 twice. That would leave me with 8. Subtract, that's 1. Bring down the 6. 4 goes into 16 4 times. So for every 96 minutes of television, there is 24 minutes of commercials. Okay, here's our percentage problem for today. What percent of 70 is 28? Okay, in this case, 70 is our 100%. And we want to know, well, what percent of 70 is 28? Not a super comfortable way to get from 28 to 70. So I'm going to suggest maybe we divide both of these by 10 and reduce it a little bit. So 70 divided by 10, we're just kicking one of those zeros off, would be 7. And 100 divided by 10 would be 10. Now, that's much more comfortable to go from 7 to 28 than 70 to 28. So 7 times 4 would give me 28. So let me do 10 times 4, and that's going to be 40. So 28 is 40% of 70. Okay, this one is a little different, kind of the first time we've dealt with this. Well, maybe not the very first time, but we have not talked a whole lot about this year. So they're asking, are these units of measurement metric or customary? Metric is a system of measuring that is used really in most other places in the world. In the United States, though, we use customary measurement. So you might not know the answer to every one of these, and that's okay. One of my suggestions are to think about what measurements do you hear used a lot in the United States? Well, I hear inch used all the time. Inch is customary. Now, meter, I don't hear us use meter too often. We know what a meter is. We have meter sticks, but we use yards more often. Like you think of football and 10 yards. So meter is actually a metric measurement. Decimeter, oh, rarely do we ever use or hear that. That's a metric. Mile, I hear that all the time. That one's customary. Foot, we use that quite often. Ounces, that might be a little bit questionable, but I want you to think about like when a baby's born and they say, oh, he was 7 pounds, 14 ounces. Okay? Or think about the way our liquids are measured in like a can of soda or a bottle of juice or a bottle of water. We actually use ounces quite often. That is a customary measurement. Grams, we don't use grams a ton in the United States. That's because that is a metric measurement and we don't use a lot of those too often. So that is how that question should look when you're done. All right, have a great day.